Hi, in this video we'll look into how to use the compare show plan option in SQL Management Studio. This feature works with any SQL server as long as you have the latest SQL Management Studio. So right now there is no ability for the developer or if you're trying to tune a query using execution plans and looking at them, it's not an easy way. I mean, there are some third-party tools, but Microsoft has brought this into SQL Management Studio, so you can compare the execution plans right in the SSMS. So to demonstrate this feature, I have a simple question that I would like to answer using two different queries, and then I would like to compare the performance between them. So the question is, how to get the most recently ended price of a product. So first there are two different tables that we are gonna use in this query. First is the production.product. So this is the master catalog of all the products in AdventureWorks database, and second is the product list price history. So this contains the history of all the prices of a product. So if you look at the data here, and there's a start date, end date, and product ID, and the list price. So if the end date is null, that means this is the current price, and if the end date has a date, that means that price has been ended. So we want to get the most recently ended price. So for that question, for example, for product 707, we would get the price $33.64. This record here will give us a price because this is the most recently ended price in 2013 for this product. So now we know what is the question. So we can answer this question using two different ways. I mean, more than two different ways, but for this demonstration we're going to use two queries to compare the plans. So first one is using cross apply, the concept of derived table, where you pass the product ID to this kind of derived table valued function, and this function will give you back with the product ID as well as the list price. So this is using the concept of cross apply. And the second one is the using the correlated subquery, which is a traditional query that that you can use on any relational database, is to get the top price or the start date. For example, in this query is to get the start date of the product, and by ordering by end date and passing that start date into the primary query, the outer query. So it's like a correlated subquery. So to compare the execution plans of these two queries, now we want to know which query performs better using execution plans, because let's run this query first. We get 293 rows here, and I'll run this query again here, which gets 293 rows. So the result is same, obviously, because it's the same query wrote in different way. So now we want to get the execution plan. As you see here, the execution finishes in less than a second. So we are not getting the actual time here, because accuracy of this time here, the duration here is only a second. So we are not getting the millisecond part. So to use the compare show plan option, first of all you need to save one of the execution plan. So to do that, we'll run the one of the query. In this case, I'm running this query with the cross apply with the execution plan included, and once I have the execution plan, I'm going to save this execution plan, and I'll go this first query here, which uses the inner join, which uses the correlated subquery, and I'm going to run this query as well using the execution plan include execution plan option. Once I have the execution plan from the other query, I'm going to right click on the query and select the compare show plan, and a message box pops up, and in that select the first execution plan. In that select the execution plan that we just saved using the one with cross apply. Once we click the open button, you can see that it stacks the two execution plans in one window, and then it also stacks the properties of both the execution plans here. So the first thing you'll notice is that some of the operators are colored. So for example, if the query plan contains, if the two query plans contain similar operators, for example, the product clustered index scan and the clustered index scan on the product table here are same on both the execution plans, as well as a clustered index seek. So you can see them are colored in the same way. So this coloring is not based on cost, it's based on the operator. So as soon as you click one of them, it highlights both the plans and the operators in both the plans, and also as well as the properties of those plans it highlights them in the both the in both the windows of this property window. So because these both are same operators. So to answer the question, which query consumes or takes more, it's more expensive than the second one. So to do that, we are going to select the select operator, which is the final operation of this query, and we can see the estimated subtree cost of the first query is 4.5. The estimated subtree cost of the second query, which uses the cross apply, is 5.8. So the cross apply, the cost of cross apply, it seems to be higher than the first query, but we don't know whether if it executes slower or if it executes faster, because we are not seeing the actual duration of the time. So now we found out that using the compare show plan feature, we figured that out, that the cost of the cross apply is higher. Let's see the actual execution time using the statistics time IO on feature. So this option, when you enable this in a query, it gives you the detailed statistics of the IO as well as the execution time and CPU time. So I'm going to run this on the cross apply here. So it took 61 milliseconds, and I'm going to run this on the the correlated subquery here. It took 222 milliseconds. So even though the cost of the cross apply is high here, in the second query, it executes faster, or it executes faster compared to the correlated subquery method, which takes 222 milliseconds, whereas the cross apply takes 61 milliseconds. So we need to understand why is the cost so high. We are executing the query in less time, but the cost is so high because the cross apply seems to use more IO. You can see the number of logical reads are, let's say, here 1012, whereas the logical reads here are 800. So it seems to utilize the resources on the system like CPU and memory properly, where when compared to the the correlated subquery, although the cost is high, so we seem to have a better performance, or the correlated subquery seems to perform faster. So hopefully you understood how to use the compare show plan option, and as well as different methods to evaluate the performance of queries in SQL Server using SQL Management Studio. Thank you for watching the video.